Okay, welcome to lesson 3. This one's about triangles, and we're going to start by learning how to classify or name triangles based on two different things. One, by the angles of the triangle, and two, by the side lengths of the triangle. So let's talk first about the angles there. If all three angles in a triangle are acute or less than 90 degrees, we call that an acute triangle. For example, this one here would be considered an acute triangle because all three of these angles here are acute angles. Same here. This angle here, and this angle over here are all acute angles or less than 90 degrees. The second one is if the triangle has one right angle. Okay, it's called a right triangle. There's one of those, it's right here. So this one's a right triangle because it has one right angle. Our last one is if the triangle has one obtuse angle, like this one over here, is more than 90 degrees, we'll call that an obtuse triangle. Okay, so one way that we can name triangles is by the angles in the triangle. The second way we can name triangles is by their side lengths over here. So if all three sides are equal, if they're all the same length, then we'll call that an equilateral triangle. None of these really seem to be equal. But if there are two equal sides in the triangle, we call that an isosceles triangle. Okay, so maybe these two sides look fairly equal. So we call this an acute isosceles triangle. Again, named off of two of its names, the angles and the side lengths. Okay. And the last one there, if there are no equal sides, if none of the sides of the triangle are equal lengths, then we'll call that a scalene. Right, so this one seems to be all different lengths of the side lengths there. We can call this an acute scalene triangle. This one, it looks like a right scalene triangle. This one looks like an obtuse scalene because none of their sides really seem to be equal in length. Okay, so in this one here, we learned how to name different triangles based on their angles and their side lengths. So one other thing we learned about triangles is what's so special about the angles of a triangle. Okay, and so the rule is that the sum of the measures of the angles, so the sum of the angles is always going to equal 180 degrees, no matter what. All three angles, if you add up all three of these, whatever x is, whatever y is, whatever z is, if I were to add up the measures of all three angles of a triangle, they're always going to equal 180 degrees. Okay, so I want you to pause the video here and see if you can figure out, based on what we've learned in lesson 1 and lesson 2 and now lesson 3, if you can see what angle x, or what the measure is for x and what the measure is for y. Okay, let's jump into this. If you happen to see, we do have a nice triangle which we've just been learning about here. Look at this triangle right here. Okay, and if I use my knowledge, I can find what x is, knowing that all three angles of a triangle equal 180 degrees. However, I don't know what this one is, and I don't know what this angle is. But I can use my knowledge from lessons 1 and 2 to figure that out. So let's look at this top one up here first. got a 75-degree angle up here. And if you remember, what we learned in lesson 1 is that vertical angles, we see this angle right up here, is vertical to this one down here. All right, they're opposite angles that share a common vertex. So if this one up here is 75 degrees, then I know that this one is also 75 degrees. Because don't forget, vertical angles are congruent or equal to each other. So I've got one of my missing angles down so far. Let's figure out this one down here in the bottom left then. Here, I see a nice straight angle. Look at that right here. Where this 140-degree angle plus this unknown angle here, since it forms a straight line, should equal 180 degrees. So if I know that this 140-degree angle plus my unknown angle must equal 180 degrees, right, because of this straight line, this straight angle here, I know this missing angle must be a 40-degree angle. Because 40 plus this 140 is 180 degrees on this straight angle, because they are supplementary. Okay, so now I have two of my three angles of the triangle. And remembering what we just learned, we learned that all three angles of a triangle should equal 180 degrees. My 40-degree angle plus my 75 plus angle x here should all equal 180 degrees, since the three angles of a triangle equal 180 degrees. I can start by combining my like terms. And if I use my one-step knowledge here, I can subtract 115 from both sides. And I will find that x must equal 65 degrees. There you go, there's angle x. And now for angle y, we kind of just talked about this one, the supplementary angles there, right? I can see this straight angle formed here between angle x, which we now know is 65, and angle y. So I know that 65 degrees plus angle y should equal 180 degrees. Since they are supplementary angles, they form a straight line down here. And when I solve, I'll find that y must equal 115 degrees. Remember that the three angles of a triangle always add to be exactly 180 degrees. Okay, the last thing we're going to learn about triangles. So again, we've learned about how to name triangles based on their side lengths and their angles. We learned that all three angles of a triangle add to be 180 degrees. And this last one is the Triangle Inequality Theorem. Make sure you note what's in this box up here. The sum of the lengths of the two shorter sides of a triangle is greater than the length of the third side. They have to add to be longer than the third side. Okay? Because what would happen if the sum of the two shorter sides was less than the third? What if one side length was 3 and one side length was 4 inches long, and the last one was 10? Right? We could not make a triangle. These two sides over here could never reach to form that third angle, right? They're too short. Even, what if they were equal to the third side? What if it was 8 for the base down here and my two shorter sides were 4 inches and 4 inches? Right? We can get super close, maybe. We can get to maybe here, right? If they were each 4 and 4, right? We could bring them a little bit closer even than that. But no matter how close we got, they would never be able to make contact and meet, right, to make up those three sides of a triangle. Eventually, what would have to happen is, for them to eventually make a contact with each other, you'd have to have a side length of 4 here, and your side length of 4 here, and it would just form a straight line. So it won't even work if they're equal. It won't work if they had to be less than the third side. It won't work if they had to be equal to the third side. The two shorter side lengths must be greater than the third side. Okay. They must add to be greater than the length of the third side. Otherwise, those two shorter sides will never meet. Okay, so take some time on this page here to see if you can identify which of these will form proper triangles. Remember that the two shorter sides must add to be greater than the third side. Okay, so let's look at this first one up here. My two shorter lengths are 4 and 5, so the big question is, do the 4 and the 5 side length add to be greater than the third? And they do. 4 plus 5 is 9, which is greater than 7. So yes, this will form a triangle. How about this one down here? My two shorter sides are 8 and 10. Will the sum of these shorter ones, 8 plus 10, be greater than 19, the third side? That answer is no. 18 is not greater than 19. So this one will not form a triangle. Up here, my two shorter side lengths are 12 and 12, so is 12 plus 12, are my two shorter sides going to add to be greater than the third? That answer is again no, because 24 is not greater than 24. Remember, we're not allowing equals to, right? They can't equal the third side length. They must be greater than the third side length. So this one will not work. And our last one down here, our two shorter side lengths are 8 and 3. So will my two shorter sides, 8 and 3, be greater than the third? That answer is, again, no. Because 11, 8 plus 3 is not greater than 13, the third side length. So in a quick recap here, the 3 things we learned: how to name triangles, based on side lengths and their angles. That was things like acute, right, and obtuse triangles, and equilateral, isosceles, and scalene triangles. Number 2, that the 3 angles of a triangle always add to equal exactly 180 degrees. No matter what the 3 angles are of the triangle, they always add to be 180 degrees. And the third thing was that the two shorter sides of a triangle must add to be greater than the third side. Right? Otherwise, the two shorter ends will never meet to form the triangle.